Our result was this. We managed to come up with a device which does integrate two clamps. You can see later for yourselves there are two transformer cores inside of that. The actual loop current measured by this device, it can be as low as 20 microamps. It's minute. That's why it's very easy to be affected by something else, and that's why the shielding has to be in place. It can measure leakage current because it has a current transformer in it, and that current could be between 16 and 400 hertz. It's cut for 600 volts, so it can be clamped outside of a building on a main power supply, and the user can be sure it's safe to do that. The measurement range is that. I mean, because it's for earthing, then there's no need to go lower, because if our earthing is as low as 50 milliohms, it's pretty good earth. Again, it has to be clamped around things, so an appropriate opening has to be there to make sure that we can clamp around tapes and other things. And if this was done in a traditional way, and only one half was being open, then that part of our trigger would go inside of the case, which would limit the amount of space we have in the middle. So what we had to do is to install a gear mechanism. So shorter traveling distance will give us greater opening. So you can see that there was effect between mechanical requirements and electronic requirements, which we had to fit all the display and other things inside. It has elongated head because it can be clamped around earthing tapes, and you see there's another example there which hasn't have that. It has only a round hole, which then makes it impossible to clamp around something which is wider than whatever the diameter of that clamp is. And because it is designed to be extremely safe, user cannot connect anything. I mean, it can store results, and you have to be able to extract those results. But because of the safety implications, you can't have just USB cable or serial cable and plug into that, because you would be able to touch the connections. So this is designed to have an infrared interface, which is there at the bottom, and can be connected to your laptop or computer, and this way export the results effectively from the device. Of course, as I've shown on one of the previous slides, a number, I mean, almost every single mega instrument will use some of the embedded current transformers. And I showed this one before, which is a very small one. If you're not careful, you can inhale it probably. But also there are some other ones, just a generic electronic current transformer, which will measure some currents for protection or for metering inside of that transformer. Because these are sort of custom designed or custom made, the number of turns then it is whatever it is to make that function we require from it. Hence, you can see on some of these that the primary is not necessarily one turn. It can be more than one turn. It doesn't matter. It's what we want to measure. And just, I mean, the one on the right is this one, and you can see how small this thing is. And this is not obviously the smaller version. You can get even smaller than that. And it's not this is not a current sensor. Well, it is, but it is a proper current transformer with a magnetic core, where you can see the primary and the secondary windings there. It can measure 7 amps apparently. We have, for the big devices installed in high voltage, high power applications, these are expensive and have very, very important implications if something goes wrong. So when we're installing a new current transformer, we have to make sure it's the right one, it's the right polarity, because if we connect it the other way around, maybe the protection wouldn't work. Is the burden resistance acceptable? And the burden resistance, just to bring to your attention, which perhaps I didn't say that above, was, as I said, we have a current transformer which is connected to another device. This wire has some resistance. I said that the burden for this clamp has to be 1 ohm. I mean, that wire will have a few tens of milliohms. That has to be taken into account. And if we have a high voltage, high power applications, the wires can run for meters. So they can be there can be a substantial resistance in those wires, and this has to be taken into account. So a device like this will be able to measure your current transformer in place and tell you whether your wire length maybe is too long. Maybe you have to increase the diameter to drop the resistance. And obviously, during operation, a number of other things can go wrong. Maybe your winding resistance starts to change because there is a corrosion involved. And if you're not careful, you will see a problem later on. But you can detect that. Obviously, you can measure also insulation resistance and demagnetization if there was a fault, for example. And I will show you exactly, I will demonstrate this in operation. There's not really too much to see because it's just the current transformer is connected and the user presses a button and then something appears on the screen. But that's how exactly the screen looks like. And we'll have test voltage, test current, and we'll have a number of things measured which are in the top right corner, which is the expected ratio which we can set up and the measured, and what is the percentage error. Is the polarity correct or it isn't? What is the saturation point? And other things. I mean, this is just one example which showing you magnetization curve. But as I said before, you can also measure resistance of the wires, of the windings and insulation and other things. I mean, this is just an example of magnetization curve. Another very important thing for professional users of current transformers is if you are a company who is responsible for installing, testing, maintaining current transformers in a field of high voltage, high power. You might have hundreds of these, thousands perhaps even. And you can't just send a technician with a tester and test it and then expect that everything will be kept on track. That's very difficult to do. So you might want to have a software which keeps a track of every single asset you've got or you have to take care of. And those results can be then dragged from or exported from that device and sort of stored in a database for every single device. And you can track the changes. So you can track that, if you do a test, I don't know, once a year, twice a year, once a month, doesn't matter, depends on application. You can see, for example, that your winding resistance begins to drop or goes high if there is corrosion, all right? Which then indicates there is a fault developing. You can do something about it. And there are programs connected to that database which can do all that trending for you and tell you that is there a fault developing. If you don't catch that fault, there will be a problem. There will be a potential disaster maybe. So that is very important also to have a software which would do that for you. And this is just an example of PowerDB, something also Mega does. And the results from most of Mega products, be it current transformer tester or double clamp earth meters, anything which records results can be connected to the PowerDB software. And there are two versions. There's a small version just for you if you want to print out and have a summary of your versions, and also the big database which will keep track of all your devices you have to take care of. I also mentioned this before, but this what you see here is specifically designed for current transformers. If you want to test the transformers, there are other devices which will do that for you, because obviously they will have other implications there. Like this is for example, three-phase current transformer tester. So you will take the turns ratio, the phase displacement for the three phases, excitation currents, vector groups, everything else. And again, you would have different versions, small or big, depends how big your current transformer is, how big your power transformer is to investigate. So that pretty much concludes my presentation, and now I'll be happy to take your questions if you have one.